In this lecture recording, I'm going to discuss coordination number from our coordination complex chapter. So the coordination number, it tells you how many bonds you have between the ligands and the metal center. So the atom of the ligand that supplies the non-bonding electrons for the metal to ligand bond is the donor atom. I can see here my zinc center, and I have 1, 2, 3, 4 bonds between the metal and the ligands, which gives me a coordination number of 4. This next example, I also see 4 bonds between the ligand and the metal center, which gives me a coordination number of 4. We can go from the coordination number to the shape. I can see this coordination number 4. I have a tetrahedral structure, whereas this I have a coordination number of 4 and a square planar geometry. And the reason for that, if I have a coordination number of 4 and a D8 metal center, I have square planar. If I have a coordination number of 4, I have a tetrahedral geometry if my metal center is not D8. And what I have here, my metal center is zinc 2+. I know it's zinc 2+ because my ammonia ligands are all neutral. And I have a charge of 2+ here, so zinc must be +2. Looking at your periodic table, D10, that's why we are tetrahedral. Over here, again, I have a +2 of my complex ion. These are all ammonia ligands, which has a charge of 0. Therefore, I must have Pt2+, which, looking at your periodic table, is indeed D8, which is why we have this square planar arrangement. So going back to these notes, we talk about the atom of the ligand that supplies the non-bonding electrons to that metal ligand bond is the donor atom. The number of these atoms is the coordination number. So here I have 1, 2, 3, 4 donor atoms, coordination number 4. 1, 2, 3, 4 donor atoms, coordination number 4. Here I can see my cobalt center. Got 1, 2, 3, 4, 5, 6. Coordination number of 6, which is my octahedral shape. And same here. Another way of drawing this, giving us a coordination number of 6, which tells us we do have that octahedral shape. So if we have a coordination number of 6, the only shape or geometry we have is indeed octahedral. So importance of this lecture slide, we're introducing again our coordination number, we're introducing donor atom, and going from a coordination number to a geometry. So here's our formal slide for a coordination number of 4. So if my coordination number is 4, I can either have a tetrahedral geometry, which is most common, or a square planar geometry. Again, a square planar geometry you will only see if you have 8 d electrons in your metal center. And you can see the drawings here from our textbook to draw our tetrahedral shape, line, line, in the plane of the board, wedge, and dash. NH3 are the ligands, N is the donor atom, so nitrogen is the atom touching that bond. N is our donor atom, really important. And then finishing the sketch off, this is a 2+ complex. The next one, square planar, so please draw this with me because on an exam you'll need to be comfortable drawing these. Will also be incredibly helpful for organic. And again, amine ligands, NH3. We can draw this in 2 dimension because it is a planar structure. And nitrogen is our donor atom. So that is the atom that needs to touch that bond. And lastly, finish off with that charge, square brackets 2 plus. So again, coordination number of 4, tetrahedral or square planar. When are we square planar? We looked at this example on the previous slide. D8, zinc 2 plus, based on the periodic table, is D10. Really common geometry is for a coordination number of 6, which gives us an octahedral shape. In this case, I see I've got, again, ammonia as a ligand. 1, 2, 3, 4, 5, 6 donor atoms. Another way to draw this, coordination number of 6. So both of these sketches are the same, just drawn in different ways. So let's go ahead and practice this together so we can get practice with our octahedral shape. So octahedral, I've got cobalt in the middle. Then I always draw my octahedral template. Line, line, wedge, wedge, dash, dash. And ammonia is the ligand, all 6 of these ligands. N is the donor atom, so that has to be the atom that is touching the bond. And again, looking at my donor atom, N, supplies the 2 electrons for that coordinate covalent bond. Let's go ahead and review the chemical formula. Cobalt first, then the ligands. Close the square brackets, 3 plus. So hopefully this was a good explanation for our different geometries and coordination numbers.